Find the vertical displacement delta y at joint A in inches. In this problem, a truss is subjected to a vertical downward point load P1 acting at joint A. The dimensions of the truss are given, and the Young's modulus and cross-sectional area are also provided, and constant for all members. Using the virtual work method, the displacement at any joint in the truss, delta, equals the sum of the virtual axial forces caused by an external virtual load, S bar I, multiplied by the actual axial forces caused by the real loads, SI, times the length of the member, Li, divided by the cross-sectional area of the member, AI, divided by Young's modulus of the member, EI. In this equation, the 1 refers to a virtual unit load applied to the truss at the location and in the direction where the deflection is to be calculated. Since the problem asks for delta y in the vertical direction, we'll substitute delta y and remember to apply the virtual external load in the vertical direction. The first step in the virtual work method is to remove the actual load P1. Add a unit virtual external load, 1, at the location and in the direction the deflection is to be measured, and then compute all resulting internal virtual forces, S bar I, to be used in our deflection equation. For example, if we isolate joint A, sum the forces in the horizontal and vertical directions, and set those sums equal to 0, the virtual tensile force in member AD equals the opposite of the virtual tensile force in member AE times the cosine of angle theta. And the virtual tensile force in member AE equals 1 divided by the sine of angle theta. Theta equals the arctangent of the quantity L divided by 2L, or 26.57 degrees. After making the appropriate substitutions, the tensile forces in members AB and AE equal -2 and 2.236, respectively. The virtual forces are also calculated for the other 4 members, and their values are shown in the table for S bar I. The second step in the virtual work method is to remove the unit virtual external load, add back the axial external loads, and calculate all member forces in the truss, which is our variable SI. As before, we can begin at joint A. Sum of the forces in the horizontal and vertical directions, set those values equal to 0, substitute in 26.57 degrees for theta and the actual tensile forces in members AB and AE, which are -2,000 pounds and 2,236 pounds. The remaining member forces are also calculated based on static equilibrium and added to the table as variable SI. Using trigonometry and knowing L equals 8 feet, the lengths of all the members are calculated and also added to the table. From our equation for virtual work, we have the virtual force S bar I, the actual force SI, and the length L. The problem statement also provided us with the cross-sectional area A and Young's modulus E. Since A and E are constant for all 6 members, these terms can be pulled out of the summation. Next, the virtual force, actual force, and length are multiplied together, and the sum of these products equals 153,434 pounds-feet. Plugging this value into our deflection equation, in addition to the area and Young's modulus, the vertical deflection at point A equals 0.00265 feet, or 0.032 inches. When reviewing the possible solutions, The answer is B.